Okay, here we go. So last time we ended with me kind of throwing it at you. We had determined basically what the requirements were of the application, and then I asked you to, what did I ask you to do?
Come up with the list of functions.
Right, and I guess implied in that's data, but I think I said, well, the data, at least the majority of data, is pretty straightforward, particularly for those media types, right? Library has those 10 fields and so on and so forth. So what I want to do, I'm not sure I felt like there was closure on it. I just want to take 10 minutes and have you kind of refresh your memories as to what you're talking about when we ended last time, and see if you can continue to flesh out any remaining bits. Again, just a short period of time, 10 minutes, and then we'll bring it back up here. We'll talk about what you came up with, and we'll look at some strategies for drawing out some of that information. Okay, so it's about 5 after now, so about until 15 after. Why don't you go ahead and do that, and then we'll pick up. Okay, so that's from last time. We'll call this more library notes.txt. I'm going to grab this information. Let's see, let me grab all this information. Anyone come up with any classes other than these? Anyone come up with any? Yes, go ahead.
I had used a database class just separately to parse and keep the parsing.
To read and parse text files, is that correct?
Yeah.
I'll say text data files.
And then with how I structured it, it also has a query method. So I basically made it like a database, and the search engine class accesses or uses the database when it is actually searching.
Did you have a search engine function?
Yeah.
Or not function,
Yeah,
class?
I had a search engine class, but I just kept that too. The only thing it has really is a search method, because I was looking at it from the perspective of like if a GUI team was actually going to use it, just a search method and a set search state method. So depending on what you're going to search.
Okay. Anyone else with anything beyond what we'd talked about? Tell me about, tell me about, here are actually some behaviors. What other behaviors have you come up for any of these classes?
We were considering a hash function for the search engine.
What do you mean a hash function?
Create a hash table for the search optimization.
Okay. Anything else? Where's the print function? Say that?
All the book periodical classes.
What else? Yeah.
We have a search function within each media class.
Okay. Anything else? All right.
I had my search functions broken out a little bit, so I had one for each type for search, call number, search. So it was 4 different types, and then the search
You had multiple search functions, you mean for these different media
Yeah,
types?
different types. So there's search call number, which the call number, title, and then what was the other one? Subject were all written within the parent class, and then the subclass, each one had a specific search other.
Right.
So there's like another media class.
Yeah, they all end.
Right, yeah, so we're not looking at inheritance yet. That's definitely a part of this project, and we will. So I'm going to finesse, or I'll ignore what you're saying about the media class. Is for this level of design, just saying they're in these four is fine. All right. So part of the immaturity of 111 students is when they're asked to do something, they'll sit down. There are a couple problems, actually. They'll sit down and bust out 300 lines of code before exiting their editor and compiling. As we are maturing, and we're now here in 511, we want to build this in smaller chunks and test as we go. Okay. Another part of that is that before you sit down and code, you have a clear idea of what it is you're coding. So I'll throw this out, and you can either contest it or agree with it silently, that right now you do not have complete confidence in all of the functionality of all the classes and how they tie together. Does anyone want to debate that assertion? Now, I'm not saying you can't get there, right? You have some mature chops, but you wouldn't be able to describe how all that code looks right now. Let me give you another sign now that we're more mature, and if you're in industry, of course these applications get larger and larger depending on the industry you're in, and you don't code the entire application. You're given a small portion of the application. Okay, so a symptom of a mature design here would be that you could code up and test the periodical class before doing any other part of the application. So that ties back into how confident are you feeling right now that you could do that? Do you feel you could code up periodical, set it aside, go on to the rest of it, having confidence that periodical has everything you need and does what you need it to do? All right. So that's the lead-in to this. So this is a sequence diagram. If you had me in 111, you would have seen this. We're essentially going to have one of these for one sequence because the application's small enough that we can pretty much capture most of it in one sequence. In an actual large or real-world application, depending on the scope of the application, when I was in industry, we had applications that we worked on that had hundreds of sequence diagrams for one application. So the sequence diagram isn't intended to cover the entire application's functionality. It's some subset of that functionality is what you use it for. So what I want to do with this sequence diagram is capture the sequence of performing a search. Now, this thick line represents everything outside the sequence, and this is your starting point for kicking off the sequence. And what I'm going to do is I'm going to put an asterisk right here, and we will say that that asterisk is, so I'll say from sequence diagram. Is asking the user for the type of search and meaning, title, call number, subjects, etc. And the search string. All right, so in production that'd be all gotten from the GUI, and that isn't your concern. When your song and dance begins, that information's already been collected. All right. what this is representing up here, these boxes, each box represents an object that is part of the sequence. Now I use the term very specifically, and I'm distinguishing between class and object. So I won't put book up here. Maybe I'll write it right here, just so that we know it's a book. But this box isn't the generic book class. This box is wind in the willows. And then this can be periodical. And this particular periodical can be about Windmills Weekly or monthly. It's big with the farming community. And so on, I'll just put a couple of them there for now. This will be we'll put our search engine here. And I don't know what we'll call this. We can call this like the card catalog. So our sequence has a book object, Wind in the Willows. Our sequence has an object, card catalog, which is of type search engine, right? Our initial contact is going to be here. So after I've collected this type of search and the search string from the user, I want to interact with card catalog with our search engine. What question am I going to ask our card catalog or search? We may call it something different from card catalog. Actually, let's see, what should I call it? Let's call it. I'm thinking to myself and thinking I want to use card catalog for something else here in a couple minutes. So, given my lack of creativity, we're just going to simply call this particular search engine object Bob. It's silly, but it's driving home that it's an object. It's not a generic class, right? This application in this sequence is interacting with that particular object, which prior to this sequence was brought into existence. Prior to this sequence, this book and this periodical were brought into existence, right? What is my interaction with the search engine? What question is, we can assume it's coming from the GUI. Doesn't matter where it's coming from. The search engine is being asked a question. Let's say that this asterisk is doing a title search in this sequence. The user wants to do a title search on wind. Yes? Can you call it what? That's kind of a blasphemous, I'm sure. No, there's no Bing in my class. Google, no, Google's pretentious. We'll go with. I tell you what, you're welcome to refer to our search engine as Robert if you prefer. All right. So, painting with broad strokes. What is it that your search engine is being asked to do? All right. Now there are a couple possibilities. Search. Yeah, so presumably the search engine has access to the entire library's catalog. So what information are you going to provide to the search engine when you say search? keyword. So I heard search type and a keyword. All right. So there are a couple possibilities here. One is, oops. So search type would be title, and that's a comma, wind. Another possibility for this is I could say search by title, and then I could just provide the one argument. So we won't resolve which is better right now, but I do want to point out that there are a couple options for us here. All right, regardless of which one it is, when Bob is asked to search by title for wind, then what is Bob going to do? So I want to, the way I'd represent this in the sequence diagram is what I'm doing in essence is I'm passing control to Bob. So if you want to look at like pseudocode for this, it'd be something like Bob dot, if I use the bottom one, or I can say string search string equals wind, and I could put right. So that's some incomplete code, but that's what that's representing. When I do this on line 41, I'm in essence the thread of control of the program goes over to our search engine. Yes? So that means that I'm right here. Now what is Bob going to do? Now I heard said look through everything for wind. Right? Give me an arrow. Where do I draw the arrow? So it goes back to, I drew it a little high. I'll erase it in a second. So it goes here. But how does, so this implies there's a relationship between Bob and this book. So one way of creating that relationship is we could look at some code here. We have, I don't know what the return type is, but I'd have search engine, : search by title, string, search string, and I have class search engine, and in the private here I've got a book. Then I suppose rather than me putting wind in the wheels, I'd call that first book. Does this strike you as what you would have?
I think I'd rather have search engine have a database of all the information so it can search through that and then go to the book to print the one that if it matches.
All right, so now we're starting to hear something getting a little closer to what you proposed. All right. So tell me about the database. It's a way of, let's just be generic about parsing it. It's a way of holding data. What are ways of holding our books in the library from C++ terms? Vector, okay. A vector, or you all mentioned hash table, right? So you could have some sort of map in there. Basically, any data structure available to you in the STL, given the simplicity of what we have going here, might serve as a means of storing all of the media in our library. Does this make sense? So I'm not gonna hold you to it, but for the sake of moving this along, I'm just going to say that this is a vector, and I'll call this the card catalog. Now, if I come over to what my code looks like, what do we put here? Vector, there's some stuff here. This is the card. I don't want to do this. This doesn't matter. I'll do camel case. So where's my arrow going to go? To the vector. All right. Someone in the outside world told Bob to search by title. What is Bob going to tell the card catalog? All right. Say that. What was that?
Final 10.
Okay.
The titles that have particular term.
Right. So now we have to get a little more specific about thinking in terms of abstraction and encapsulation. So vector, let's assume that the vector is a thing, and let's assume that it is some properly encapsulated abstraction. According to number 2, the only thing that we can do with the vector are those interfaces that have been made publicly available. So my question to you is, are the C++ language designers who put the vector template class into the standard, did they provide a search by all the titles interface? No. What are the things that we can do with the vector? We go to here, we say vector C++, comes up here, looks like I've clicked on that once or twice in the past. And here it says member functions. These are all the things that we can do with the vector. So what is something that we'll do with the vector? Iterate through it. Good. Okay. So when you're going to, how many times are you going to iterate through it? Huh? I'm sorry. How many iterations are there? How do you find out how many as there are? There it is. So here's a member function called size. That's something we can do, yes? Now it's going to do whatever it does, and this is where the drawing gets a little bit different. And what I'm going to do is I'm going to make this a dashed line. So this dashed line means, in essence, it's a return statement. It's a relinquishing of control. Yes?
So this is assuming that we already read in all of the data in some specific way?
That's correct. This assumes that we've already read in the data. So I said it a different way, which is this sequence already assumes search engine exists and these books exist. So there were other sequences that occurred prior to this one. So again, the arrows end up being member function calls, if you will, and the dashed arrows are return statements. So we're giving control to Bob. Bob is, for a moment, giving control to the card catalog, and now the card catalog is giving control back to Bob. How does that? That's a very long-winded way of just simply saying I actually don't like the camel case. Yes, that's that portion of the sequence diagram.
What was the size of
Why are we getting the size?
Yeah.
Because, why are we getting the size of the vector?
So we know how many iterations to run.
Right, our card catalog is filled with the 200 and some odd, it's a small library, record media in the library, and so we will iterate that many times. And just generically, why are we going to iterate the 200 and some odd times? What is the reason for iterating? Yeah, okay.
To find all the cases where the title matches.
Right, right. We need to, in this dumb search, we need to go through everything in the library to find what matches when. So that's our motivation for getting the size and getting the iterations. Now, the sequence diagram is actually fairly poor at doing iteration. So I'm just going to kind of bust this out as a separate line representing that an iteration is happening. I've gotten the size, so this is for, we'll say I equals 0 to size. Yeah, you could definitely do this with begin and end, but it'll cramp my hands. So I'm going to go for the kindergarten way of iterating through this. Okay, so I've gotten the size. I start a loop. What am I going to do in the loop?
I'm just going to say find all matching cases. Title, what does return?
So, okay, yeah, I heard some things that'll be good to talk about here in just a minute or two. I right where I have this, oops, not that. Right where I have this dot, an arrow needs to be flying out into the world here. Where is it going to go to? Catalog. Good, I'll buy that. And, whoops. What question is it going to ask, or what command is it going to give to our good friend Vector? It's got to be in here. It's got to be an interface that Vector can respond to. That's all we can do with Vector. Any arrowhead going to Vector has to be part of the public interface. So, get the ith item. So I'll just do, I could either put, I'm going to put 0 here. Maybe I would be better. But this is just emphasizing that in this sequence, I'm getting that first item, at least the first iteration, right? As I said, the sequence diagram doesn't do really well with iterations, so we're kind of kludging here. What this looks like, if we're going to code, is now the Bob's search engine is, here's our code. I'm going to there, get some color. So what I'm doing here is I'm saying card catalog sub I. So we have some loop for int I equals 0, I is less than sc, plus plus I, and we've got, I've got some pseudocode going on here. We don't have it all filled in, but I have some XYZ variable, and I'm getting the ith item from card catalog. Yeah? That's what we got going right there. So this is control coming back to us. Whoops. And I'm going to erase this, make it dashed. It's giving us wind in the willows. Now what happens? So my arrow is going to, whoops, I'm sorry, this arrow should have gone a little bit further. Let me, so keep, let's look at this. What am I going to do on line 16?
I would do a find on the return string for
What is being returned? So I said what was being,
The first step, the I.
what is our vector full of? Media objects, right? Now, are they pointers? Are they actual objects, right? It doesn't matter at this stage so much. they're filled with media objects. So when I do this and I get the 0th item, what am I? I'm getting back a media object. Once I have the media object, then I can interact directly with that media object. And I said, because I'm an evil dictator, I said this one's going to be the first one. So that's the one we talked to first. I know you all were hoping for the periodical because you're interested in a little more information about that windmill thing. But I'm the teacher. I'm mean. It's going to be the wind in the willows. All right, you got the object. What are you going to ask the book? There's another way of doing that. So, all right, let me actually, before I do that, let me roll with where y'all are going with this for a little bit.
Didn't you say, like, getting something like this was not allowed?
Didn't I say doing just the get like this is not allowed? Not exactly. So first, let me. I think what I was trying to say is that a big design faux pas is to immediately fill your class with a bunch of getters and setters, and now your class is little more than a data structure holding together 10 different variables, and it has no behavior in it, right? I mean, literally, why have the getters and setters? Why don't you get rid of all the member functions and literally make it a C-style structure, which is just in C++ parlance, it's just a bunch of public data. And then why have all the extra getters and setters? Just get and set the damn thing directly, right? So someone who doesn't know how to design, their first inclination is to make everything a getter and a setter. That isn't to say that getters and setters are wrong. There are many, many cases where they're absolutely a proper part of the design. But don't start from the assumption that that's where you begin. All right. And stand by. I got more to say. Once it comes back here, so what we get here is the title. I'm gonna actually put in quotes here. Wind in the willows. I'm going to abbreviate. So that's what's coming back, right? That's the thing being returned. And I should probably show that there's some number coming back here. This is going to be a book object, some sort of annotation, so you know it's being returned. You could even say void if nothing's being returned. In fact, I should probably say the wind in the willows book object, but I just don't have enough real estate, so I won't. Wind in the willows comes back. Now what are you going to do? All right, so here's what I'll do is I will put a little tick mark here to show we have a little bit of behavior happening inside of Bob. So Bob is going to compare. I wonder if I can. The book's title to wind, which I won't say it here, but is the argument that came to us, yes, from the function call, either, depending on which one of these we're using, either this one or this one. And unfortunately, I'm going to have to make this so small it's not readable. Ooh. All right, what was the statement that was made? You understand that if that's cut off, and that's corresponding to that little hash mark right there. Yes, you're absolutely. It is a contained search, so there will be kind of a string within a string thing being done. Find, I think, would be the member function you would call on a string type, and it would tell you whether it's in there or not. Yes, absolutely. I'll just stick with generally compared, and we all know what that means. Okay. Oh, damn, we are already out of time. You able to hang with me for 2 minutes? Absolutely not? Okay, no, that's, yeah, I know you'll get overtime for this, but let me give you, so I'm going to say that this is one possibility. Now I'm going to give you another possibility. Mm. Come on. There we go. This has some funkiness as to whether it'll draw a straight line or not. And I haven't quite deciphered why it sometimes does and doesn't. Yes, we need to hold that out as an option. We don't have time to talk about it now. Can you hold that thought and absolutely talk about it on Monday? All right, so don't lose track of that. So what's this going to return? If the comparison happens here, what gets returned?
True.
True or false? All right. So here is where we as designers have debates. Where do you put the algorithm? Now, you and I both know this. When I say algorithm, I'm using the word charitably. It's a string comparison, right? It's a one-liner. But increase the complexity of my toy example, and this algorithm could be dozens or hundreds of lines long. Yes? Is it better to ask the book for the title and have the algorithm in the search engine? Or is it better to simply ask the book to compare title and have that algorithm inside the book? You understand the distinction? All right. So just let that roll around in the back of your head. When we pick up on Monday, we will debate this. And we'll also look at the idea of, well, what if you just have book print everything? Okay? All right. We'll see you on Monday.
If you farm out the comparisons, searching